Hello guys, welcome back to this channel. This video is about how to control AC load using a proximity sensor. This is the load, a lamp. And also the easiest way to see how a proximity sensor works in our everyday life is through the use of smartphones. They turn off the screen when you hold the phone to your ear during a call. That's the work of a proximity sensor installed in the phone. It is at where the camera is. The moment you bring your hand or any other object to where the camera is during a call, your phone screen is actually going to go off. And even when you are listening to audio on WhatsApp and you hold the phone to your ear, the screen is going to go off. That is the work of a proximity sensor. And I think you have seen this several times. That is that. And a proximity sensor is a device that detects the presence of a nearby object without any physical contact. We also have them in different types. That is the inductive proximity sensor, capacitive proximity sensor, photoelectric proximity sensor, and ultrasonic proximity sensor. We have more, but we are actually going to focus on inductive proximity sensor. That is what I'm having right now. Now, this inductive proximity sensor only detects metallic objects. It detects metallic objects using an electromagnetic field. Capacitive proximity sensor also detects changes in the capacitance caused by the presence of an object. It can be used to detect both metallic and non-metallic objects. That is the capacitive proximity sensor. You also have the photoelectric proximity sensor. Now, this photoelectric proximity sensor uses a light beam to detect objects. You could see that there's a light over here. When the sensor is active, you could see that there's a light over here. That is the photoelectric proximity sensor. When an object comes into contact with the light, then it activates or deactivates a circuit. That is the photoelectric proximity sensor. And we have the ultrasonic. The ultrasonic uses a sound wave to detect an object. When you either clap or shout, then it either activates or deactivates a circuit. That is the ultrasonic. And as I said, we are only going to focus on the inductive proximity sensor. That is what I'm having right now. This is inductive proximity sensor. It detects metallic objects only. Now, you could see that we have 3 terminals over here. And if you want to know how this proximity sensor works, you have to look at the top right here. We have the wiring diagram over here, and I've also drew it here. This is the wiring diagram of the proximity sensor. We have it written here. You could see that we have BN, that is the brown wire. We have it here. BN, brown. We have BK, that is the black, BU, blue. So over here is positive. The brown is positive. We have the BU as the negative. And you could see that we have a tapping. This is a tapping. We have everything written here. This is a tapping. This is the negative line. It is being tapped to this rectangle we have here. So if the negative side is being tapped to this rectangle over here, then technically this is the positive. This rectangle you see here could mean a coil, a relay, or a contactor, or something like that, or even a load. So if the negative line is being tapped to it, then automatically the black becomes the positive. That's the output. So if the proximity sensor will work, you have to connect the positive and the negative to a load before it will work. So technically, if you have the negative connected to the load and this is another line coming to the load, then technically this side is the positive. That's the way it works. And if you look at this, you can see that there's a normally open contact here, meaning this is normally open inductive proximity sensor. And we have the black as the output signal. You can also say that this is PNP proximity sensor, meaning the output signal is positive. If it is NPN proximity sensor, it also means that the output signal is negative. This is the negative, this is the positive. And over here is the output cable. This negative is connected to this load. And over here becomes the positive output. So we are going to wire this proximity sensor to control this load. This positive and negative terminals is actually saying that the proximity sensor uses a DC voltage. That is from 10 to 30 volt. That is the range 10 to 30 volt DC. It will work. We also have the current rating here. That's the output current rating. This is 200 milliamps. You have everything written here, and we are going to wire it to control our load. This is a DC proximity sensor, and in order for us to use this DC proximity sensor, we are supposed to use SMPS. This is the SMPS. This SMPS you see here is what is going to help us convert the AC voltage to DC. We have the input here and the output, and with the input we have 3 terminals. This is the earth, this is the live, and this is the neutral. And the output, we have 5 terminals. You have 2 of them here as the positive and 3 of them here as the negative. So in order for us to use this DC proximity sensor, we have to use this SMPS. And in order for us to control the load using this DC proximity sensor, we have to then use a relay. We are going to connect the proximity sensor to this relay you see here. This is a magnetic relay, and we are going to use the relay, the normally open and the normally closed, to control the load. The sensor is going to help us energize the relay. This is 24 volt DC relay. You have it here. This is 24 volt DC relay, and that is what we are going to use to control the load. The sensor is going to energize the relay, and the relay is going to open the way for the current to flow to the load. So let's get started. Over here is the wiring diagram on the relay. This is the coil and this is the base or the socket. We have this wiring diagram on the coil. You have it here. Yes, this is it. I have a video about relay basics, so if you want to learn more about relay, you can actually check the description down below. If you are watching this video on TikTok, you can actually go to my profile and check my bio. I have my YouTube link over there. You tap on it to take you to YouTube. You just check my first 20 videos. You could see that I have relay basics tutorial video there. You can check it out. We are only going to focus on the numbers in the bracket. We have 9, 10, 11, 12. We also have 8, 7, 6, 5, 1, 2, 3, 4. We're going to focus on the numbers in the bracket. This 9, 10, 11, 12, they are common terminals. So if you want to use any terminal here, you have to then connect your live to this number 9. This is normally open, and this bar is linking to this side to the number 1. That is the normally close. 5 is normally open. So when the relay energizes, this bar you see here will disconnect this line, then come and link to this one. And when it de-energizes, it's going to disconnect from here and come and link to this side. That is the way the relay works. We also have the coil. This is the coil terminal. You have A1 and A2, and A1 is the negative and A2 is the positive. You have 13 and 14. What you could see on the socket is numbers. You have numbers, and it is the same numbers here. So if you want to wire it, you have to look at the numbers and you use it to wire it. So let's get started to the connections. I'll connect this cable, the red as the live and the green as the neutral, from the breaker to the SMPS. This side is the live. Okay, from the live to the SMPS. This is the live terminal. Okay. We have the neutral. Yes. This is the neutral. Okay. Now, as I said, this proximity sensor, we have the brown, the BN as the positive, that is the brown wire. And we have the BU, that's the blue, as the negative. And we have the black here, that's the output cable. I'm going to connect it to the relay. So what I'll do is to connect the brown to the positive side of the SMPS and the blue to the negative side. The negative, as I said, we have 3 terminals, so I can connect it to any of the 3. I'll connect it to this side. The brown as the positive. Now this is the output, the black. When the proximity sensor detects the presence of an object, this open here is going to close, and then there's going to be a current flowing through this black cable to the relay. That is what is going to happen when this open closes. What I'm going to do is to connect this positive side, the output, to this connector, and from the connector to the relay. Okay. This is the positive, and the positive is connected to the, we have 14 and 13, and 14 is the A2, that is the positive. What I will look for on the relay is number 14, and 13 is negative. We have number 14 down here. This is 14. This is number 4. There's an arrow over here pointing to this side. So this is the 14 terminal. Connect the positive. Okay. And in order for the relay to work, I have to also connect negative signal from the SMPS to the relay. And that is what we have here. There's a tapping of the negative terminal on the SMPS. So what I will do is to connect a cable from the SMPS, the negative side, to the relay. And I'm going to connect it to number 13. That is the A1. This drawing you are actually seeing here is found on the relay, as I said earlier. We have everything written on the relay coil. I will use this green cable and connect it from the negative terminal on the SMPS and connect it to the negative terminal on the relay base. And as I said, we have 3 of them, the negative terminals. So I'll connect it to 1. Okay. This is number 13, that is the negative. Guys, we have successfully connected the proximity sensor to the 24-volt DC relay. So what I'll do is to insert the coil. Okay, I will operate it to see how it is going to work. I'll turn on the breaker. This is inductive proximity sensor, and when it detects the presence of a metal, then it is going to activate or deactivate a circuit. So look at this. So right now, the relay is working. The clicking sound. You could also see the diode up here. And sometimes it depends on the sensing range. If the sensing range is very high, even if you bring the metal, something like this, it is going to work. But if it is low, unless you bring it very close to the sensor. So even if I touch the sensor with it, it is still going to work. And when I bring it upwards a little bit, it's still going to work. As I said, if the sensing range is very high, even if the object is like this, it's still going to work. And if it is low, unless the object comes very close to it before it will activate. There's an indicator over here. When the sensor is working, it will light up. Now, we want this AC load. This lamp you see here uses 230 volts. That is the live and the neutral. So in order for the lamp to work, you have to supply live and neutral cables to the lamp holder terminals. What I will do is to connect it from the neutral side of the circuit breaker to the lamp holder. Okay. From the neutral side to one terminal of the lamp holder. Okay, this is a 24 volt DC relay. Right now I've connected positive and negative signal to the relay. That's why the sensor was able to activate and deactivate it. So what I will do is to, as I said earlier, these are common cables. If I want to use this side, I have to connect a live cable to the common. I also want to use this side, I have to then use a jumper to loop the live to this side. But in this case, I'm only going to use this side. So I'm going to supply a live cable from the breaker to the common terminal on the relay number 9. I'll connect this red cable from the circuit breaker, the live terminal, to the relay. Okay. We have number 9 at this side. This is number 9. So what I'll do is to connect the live to number 9. Okay. We have number 5 and number 1. And number 5 and number 9 are normally open terminals. We have number 9 and number 1 as normally closed. So if I want my load to work when the relay energized, then I have to use the normal open. That is the number 5. We meant the relay energized. This normal open here is going to close. So I'll connect a cable from number 5 to the load. And that cable is going to be the switch wire. We have number 5 at this. This is number 5 and this is number 1. Number 5 is the normal open and number 1 is the normally close. From 5 to the lamp holder. This is number 5. To the lamp holder. So guys, we have successfully connected all the needed components to be connected in the circuit. So what I'm going to do is to insert my lamp itself. This is a screw type, so I'll then screw it. We have our lamp successfully installed. This is the inductive proximity sensor. I'll then turn on my circuit breaker. When this proximity sensor detects a nearby object, then it's going to activate or deactivate a circuit. So what I'll do is to bring in my tester, the metal part, that is the bit, to the proximity sensor. This is inductive. Okay. So guys, right now our circuit is working perfectly. And I explained a proximity sensor as a device that detects the presence of a nearby object without any physical contact. But then I'm actually touching the sensor with this electric tester physically, and it is working. You can also do it like this and it will work. The sensing range is too low, so right now it is not touching it and it is working. The sensing range is too low. If I bring it something like this, then it deactivates the circuit. If I bring it like this, and it will start working. I connected the switch wire to normally open. That is why when the relay energizes, then the load will also start working. If I connect it to normally close, this is the switch wire. If I connect it to normally close, automatically it will start working. But when they really energize, then it will stop working. So let me remove the cable from the normally open side to the normally closed section. Safety first, I'll turn off the breaker and remove it from the normally open. I'll connect it to the downside. This is number 1, normally close. Okay. So right now, the load is working without any contact with the proximity sensor. We have number 1. Number 1 and number 9 are linking directly. The moment they really energize this bar, so you're going to disconnect this line and come and link to this one. So when I touch the proximity sensor with my tester, it's going to disconnect this side and come and link to the normal open. Okay, so right now it's working as I said. The indicator on the relay has light up. When I remove my hand, I touch it with it. So guys, if you find this video helpful, consider subscribing to this channel and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Thank you for watching this video and see you in my next video. Bye.